Hello and welcome to the exercise Create a multi-slope cut and fill with a cut ditch. In this video we're going to create ditch end conditions. We're going to show you how to create parametric constraints, resolve priority conflicts, and finally how to test those end conditions and verify their operation. Our goal is to design an end condition component with a safety slope, a flat bottom symmetrical ditch with a 1:2 slope tie. Then we're going to take that component and add it to our previously created template. So to get started, as always, we're using the delivered Bentley workspace. So use the examples user, project Bentley Civil Imperial, Bentley Civil for your interface, templates.dgn, create template tool, and finally we're going to load the course library file. That should bring you to this point. I'm going to right-click on the template library up here, click New Template. I'm going to rename that template Cut Ditch Interior. I'm going to right-click, say Add New Component. It will be an end condition. Then I'm going to come down here to the current component properties, rename it Cut Ditch Interior 1:2. It's going to be the grade cut feature. We're going to give it a priority of 8. And we're going to look for or target the terrain model and set that to the active terrain model. We're going to come over to our dynamic settings box and select the point name from our drop-down list. This is going to be our hinge. We're going to set the key in to XY and type in 0, 0. Now what I want to do is uncheck these boxes here. I don't want to check for interception for our ditch, and I don't want it to be infinite, so I'm going to clear all those. I'm going to set our point value, again selecting it from the list. That's important. This will be our ditch top. And you'll notice the point style changes. And I'm going to change the key in to horizontal and slope and key in the values 8, minus 10%. Going to hit enter, and there's our ditch top. Next, I'm going to pick ditch for slope from the drop-down list. This time my value is going to be 6, minus 1:3. You'll notice that in one example I entered the slope as a percentage, and the next I entered it as a ratio. Either one is valid. Now we're going to place the ditch bottom, again picking it from the list. Slope value for that is going to be 4 foot at a 0 slope. We've got a flat ditch. Then we're going to place the back slope. Value for that will be 6, 1:3. Now for this last point, we want to tie back into the existing ground. So we do want to check for the interception. We do want to place a point there, and we want to make it infinite. This point is going to be a cut, so I'll select cut from my drop-down list. And then I'm going to modify that name and call it cut underbar 1:2. So again, pick the point from the list, then you can call it whatever you want. Finally, my horizontal slope is going to be 3, 50%. And even though I've keyed in 3 foot there, we've set it the end condition to infinite, so it will go out as far as it needs to intercept the existing ground. Go ahead and hit enter, right click, finish, and our component is created. That all looks good, but you always want to test it first. So I'm going to click the test dialog here. I'm going to zoom out just a touch. Remember that you always have to have your available target. I'm going to put in about a 3% slope and click draw. Now you can see that because we didn't check for interception on any point of our ditch bottom, we only get it solved when we come back into that cut. Anytime you have a component that works the way you expect it to, you always want to come up to your library and save it at that point. Now what we want to do is add what we refer to as parametric constraints to our template. So to do that, I'm going to double click on my ditch for slope. And you'll notice down here in the constraints dialog, it has the attributes for the first constraint being a slope and the second one being a horizontal value. Parametric constraints allow you to override these values either during the design session or actually during the corridor creation. To set that functionality up, we need to enter a label. This becomes the parametric constraint. So for here, I'm going to type in ditch slope, and for this one, I'm going to type ditch slope width. Always remember to click the apply button once you've made your changes so that those changes get applied to the point. Once you hit the apply button, then you can close this dialog. We're going to move over to the ditch bottom now. We might want to apply some parametric strength to that, to the ditch slope or to the horizontal value. So we'll key those in. Ditch bottom slope and ditch bottom width. Again, we're going to click apply and close. And finally, for the ditch back slope, this is a symmetrical ditch and we want to keep it that way. So we're going to add a little trick here. When we come to applying the constraints for this point, what I'm actually going to do is click this little down arrow here and you can see the two values that we had before. So I'm going to apply the ditch slope and the ditch slope width. So that's going to mirror our points values from the previous selection. However, because this ditch is going to be a mirror of the previous one, we need to add a negative sign to the slope value. Once that's done, go ahead and click apply and close. Now what we need to do is test this. So the way you can test parametric constraints is come to the Active Templates tab, open up the parametric constraints. You can see the different parametric constraints that we've created. The one I want to modify is the ditch slope, and you can see a drop-down list of the point that it's directly controlling. So what I'm going to do is double-click on that. I'm going to enter a value -1 to 1, so a 50% slope. Now with this dialog, it's critical that you hit the Tab key to enter that value, and then I'm going to click OK. And now you see that that template was adjusted for that new value and on both sides. So that works exactly like we want it to. So I'm going to set that back to a 1 to 3 slope. Again, hitting Tab and OK. And I'm going to save that template. Now that we have our ditch working the way we want, we have one final step in this module, and that is to take these components and create a new template. So I'm going to call this Combo 1, and what I'm going to do is drag and drop both components that we created in prior exercises into a complete template. Before I do that, however, I'm going to make sure that I have the step value in my dynamic settings dialog set to 0.1. This sets up an invisible grid and will make the next step much easier. So I'm going to come over to our cut and fill, and you'll notice that the active template is still our combo with the red box around it. I'm going to drag the cut and fill here, left click and hold that button, and now you can see why I set the step value to 0.1. As I move, that X and Y value changes. So I'm going to wait until I see 0, 0 there, the origin of the template, and release the left mouse button. So I had it held down that whole time. That drops that template, or that component that we created, into this new template. And now I'm going to go get our new ditch. Again, I'm just going to click the left mouse button and hold it. Bring it in here until I see that hinge point highlight. That means that that point is going to be shared, and then I release the left mouse button. Now what we want to do is we're going to delete this 1 to 2 slope here. So I can right click out in space, say delete components, and then I'm going to left click and hold the mouse button down, and this draws a little squiggly line that when I release the left mouse button, it deletes those components. That looks pretty good. So now we always test our components to make sure we get the functionality that we expect. I'm going to set this to something other than 0% and click the draw button. And now you can see our different slopes are processing. But we have an anomaly here. As the cut side comes in, you can see there's a situation where we have our ditch process for a little bit, when probably we wanted this fill slope to process. So other than that, this template looks pretty good. So how do we correct that? Well, I think we can do that just by checking our priorities here. And the software says that we don't have a problem, but it's not quite working the way we want. So we want to edit that hinge point. And the problem here is that our cut ditch is processing at points when we really want that fill 1 to 4 slope to process. So what I'm going to do is change this to 3, To bump it above that cut ditch, click OK. I'm going to close this dialog, and now I'm going to test again. And the cut side the fill side looks good, and now the cut side as well. So again, always check the functionality and test your templates to make sure that they work the way that you expect them to. I'm going to go ahead and close this. So to sum up, parametric constraints are simply created by filling out the constraint label field in the point properties dialog. They are very powerful during the design process. You can create a template with a dimension for a lane width, and through parametric constraints change that lane width through a transition or to add multiple lanes. They can be tested within the editor by selecting the Active Templates tab and modifying those values. And once they're created, it's a good idea to pick them from the drop-down list to avoid any typos. Also, if you create your end conditions as components, and you can build a standard library that can be quickly assembled into templates for each project. And always test and verify that your end conditions behave as expected. Thanks for watching, and I hope to see you in the next video.